Hello friends, welcome to our YouTube channel Basics of Physics. In our today's online session, we'll be discussing some of the important multiple choice questions based on the first module of MSc Physics Theory course PHCT 122 Atoms and Molecules as per the syllabus of Savitribai Phule Pune University. These questions which I'll be discussing in our today's session, these are important for the various online exams which are going to be held in this month, and also the some of these questions has appeared in the national entrance exams such as CSIR NET GATE and also for the state eligibility exam which is conducted by the Pune University SET. So let us start with our today's session. First question is, the atomic model based on classical and quantum analogy is. The options are: first option Rutherford atomic model, option 2 Bohr's atomic model, option third Vector atomic model, option D Dalton's atomic model. Now we know that this Bohr's model, it was proposed in the year 1913 by the scientist Neil Bohr, which was based on the concept of planetary motion of planetary model. And this one we had seen the necessary force which was required for the circular motion, it was provided by the electrostatic force. So it is the this model basically uses the classical ideas also in order to explain why the electron does not radiate when it is revolving around the nucleus. He has used the some concept of the quantum mechanics, and when an electron jumps from the higher energy orbit to the lower energy orbit, it emits a photon. So these three postulates we had seen in the planetary model, and this both uses the classical and the quantum analogy from the physics. So the correct answer for this question is the option number B, Bohr's atomic model. Second question is, an subshell occupied by electron in an atom is represented by. The option is A option S P D F, option B K L M N O, option C A B C D, option D L L S J. We know that a subshell occupied by an electron in an atom is represented by orbital quantum number, which is represented by the letter small n, and which can take values from 0, 1, 2, 3 up to n, where small n is the principal quantum number, and the corresponding values of subshell or name of the subshells are L equal to 0 corresponds to S orbit, L equal to 0 corresponds to S orbit, then L equal to 1 corresponds to P orbit, and so on. So the correct answer for this question is the option number A, which is ESPDF. So a subshell occupied by an electron in an atom is represented by the letters S, P, D and F and so on. Third question is, for L less than or equal to S, the multiplicity is given by. The options are given over here. We know that for a given electron configuration, the term with maximum multiplicity has the lowest energy, and this multiplicity is equal to the number of electrons plus 1. Okay, so in this case the total multiplicity, it is given by the value 2s plus 1, and so therefore the term with lowest energy is also the term with maximum s and maximum number of unpaired electron. So in this case, if you look at the option, it is the option number A, 2s plus 1. Next question is, for pp electron configuration, the values of total spin angular momentum S are. Options are 0, 1, 2, option B 0, 1, option C 2, 3, 4, option D 0. Now we know that for pp electron, the orbital quantum number, that is L, has a value 1. So for these two electrons, value of L will be L1 equal to 1 and L2 equal to 1. And we know that the spin of the electron, it is given by the half. The spin quantum number can take value S equal to 1 half. So we want to calculate the total spin angular momentum. So total spin angular momentum, it can go from S1 minus S2 to S1 plus S2. So if you add these two and if you subtract these two, so 1 half plus 1 or 1 half minus 1, it will give you the value 0 comma 1. So if you have a pp electron configuration or any kind of an electron configuration, you will get the value of spin angular momentum, that is 0 and 1. Okay, so the correct answer for this question is option number B. Fifth question is, in sodium atom, the transition occurs between 3p level and 3s level. The series is known as. The options given are sharp series, option B principal series, option C diffuse series, option D fundamental series. Now see, we had seen in our regular lecture what is sodium atom energy level diagram is and how this sodium atom energy level diagram is prepared. We had seen, depending upon the different principal quantum number, you have different values of L. For example, n equal to 1, you have L equal to 0. uh, for n equal to 2, you have L equal to 0 and L equal to 1, and so on. In this fashion, we have different or L's levels for a given number of principal quantum number. Now, if a transition is from L equal to 0 level to any other level, then that is known as the S series. Okay, and if the transition is from the D level to any other level, then it is called as a D series. Or if the transition is from P level, for example in this fashion, to on any level, okay, then it is called as a P series. So this way the nomenclature is given. If the transition is from the P level, then it is called as a P series. If the transition is from the D level, then it is called as the D series, that is diffuse series. Okay, in this case it is given that 3P level to 3S level, the transition it is given. So P to S level, if transition it will be there, then it will be called as a P series. So P series corresponds to principal series. So the answer for this question is option number B, that is principal series. Here you have to consider one more thing, is that in case of a sodium atom, we call a sodium atom as an approximate monochromatic light source, because it gives you the wavelength of 5890 and 5896 angstrom, depending upon the transition from P level to the 3S level. So this way, this transition is very important. If you consider, when an electron is moving from 3P level to 3S level, it emits an wavelength of 5890 and 5896 angstrom. Okay, because P level has a doublet, and corresponding to those two doublets, that doublet level, you have a two wavelengths emitted from that one. These two wavelengths are very placed close to very close to each other. That is why we call it as it is a approximate monochromatic source. Next question is, the energy of an atom is determined by, option is inner core electron, option B middle core electrons, optically active electrons, and option D any kind of electron. We know that in the analysis of optical line spectrum of any alkali atom, in terms of its excited state, this is very simple, since the excited state can be described completely by the optically active electrons, and in this case core electrons can be ignored, because the core electron just add some constant value in the total energy of an electron. So that is why the core electrons can be ignore, and we have to just think about the optically active electrons that we had seen in a Hartree theory. Okay, so if you look at the option, in this case it is the optically active electrons which are prime for the determination of an energy levels of an atoms. So the correct answer for this question is the option number C. Seventh question is, orbital quantum number determines, option A shape of the orbit, option B radius of the orbit, option C orientation of the orbit, option D uh, energy of an electron. We know that the number needed to specify the orbital, that is L, that is called as the orbital quantum number or orbital angular momentum quantum number. This orbital angular quantum number has no role in determining the energy of an hydrogen atom. We had seen that in the Schrodinger atom. And this uh, orbital angular momentum quantum number, it represents the magnitude of orbital angular momentum of an electron which is revolving around the nucleus, that we had seen. So if you consider this orbital quantum number, it relates to the shape of the orbit in which the probability of finding an electron, it is maximum. So the if you look at the option, then it is the option number A, which is the correct answer for this question. So the question reads like this: orbital quantum number determines the shape of the orbit. Option A is the correct answer. Next question is, in weak magnetic field, which effect is dominant for splitting of energy levels? The options given over here are normal Zeeman effect, anomalous Zeeman effect, Paschen-Beck effect, and Stark effect. Now we have studied that here in this case the weak magnetic field is given, and in our theory lectures we had seen when an atom is placed in an external magnetic field and then it is excited, the spectral line it emits while de-excitation process, these lines are splitted into various components. Okay, so this phenomenon is called as the normal Zeeman effect. If it is a weak magnetic field is there, then it is called as a normal Zeeman effect if the spin part is absent. Okay, if atom does not have a spin, then it is called as a normal Zeeman effect. Now what happens if the spin will be there? If the spin will be there means non-zero spin will be there, then in a magnetic field these lines will be splitted into large number of spectral lines, that is more than 3. In case of normal Zeeman splitting, you have just a 3 number of lines. Okay, in anomalous Zeeman effect you have more than 3 lines. Okay, such a effect is called as the anomalous Zeeman effect, but the necessary condition for that, it is non-zero spin you must be having for that case. Now if you apply the strong magnetic field instead of weak magnetic field, if you apply a strong magnetic field, what happens? This anomalous Zeeman pattern, it changes to the normal Zeeman pattern, and this splitting or this effect is called as the Paschen-Beck effect. And in case of a Stark effect, we know that magnetic field is not required, it is an electric analog, so you will be requiring a electric field for that purpose. So if you look at these options, so it will be both normal Zeeman effect and the anomalous Zeeman effect. But here in this case, spin component it is not given, so we have to pick an answer which is more general. So it is the anomalous Zeeman effect, which I feel is the correct answer for this question, which is option number B. Ninth question is, for an atom, if n is equal to 6, the total number of electrons in a given shell are 72, option B 36, option C 6, option D 12. Now we know that the number of electrons in any given shell are given by number 2n square. Okay, and here in this case for a given atom n is equal to 6, so if I do 6 square multiplied by 2, the answer will come out to be the 72. So if you look at the option, it is the option number A, which shows if an atom has n is equal to 6, that is sixth subshell, it will have 72 electrons capacity. 10th question is, if L is equal to 2 and S is equal to 3 by 2, then multiplicity is, the options are A is 3, B 4, C 5, and D 2. Now we know that for a given state L and S values are given, which is nothing but the 2 and 3 by 2. Now multiplicity of an state, it is given by the value 2s plus 1. Here in this case the spin of spin it is given, that is 3 by 2, so it is 2 into 3 by 2 plus 1. So if I simplify this one, it is 3 plus 1, which will give me the value 4. So if you look at the option, it is the option number B, which shows the correct answer. So if L is equal to 2 and S is equal to 3 by 2, then the multiplicity is 4, option B. Next question is, for the existence of a singlet, and triplet state, the possible values of S1 and S2 are. The options are given over here: 1 half, 1 half, 1 half 3 by 2, 1 half, 1 comma 2 and 1 comma 3. These are the four options which are given over here. Now we know that for any electron, in order to have a singlet and triplet state, okay, what we will do, we will consider these options. First of all, let us consider the option number A. Option number A, for which S is equal to 1 half and S2 is S1 is equal to 1 half and S2 is equal to 1 half. These are the two spin states. These are given over here. Now we know that the total spin angular momentum that will be given by sum and difference of these two spin states. So it is S1 plus S2 or S1 minus S2. If I substitute these values of S1 and S2, that will be 1 half plus 1 half or 1 half minus 1 half. So that will nothing but it will give value of S equal to 0 and 1. So which are nothing but the triplet. For S is equal to 0, you will get the multiplicity it equal to 1, which is a singlet state, and for S equal to 1, you will get a multiplicity is equal to 3. Based on this formula, multiplicity is equal to 2s plus 1. So for these two states, you are getting a singlet as well as the triplet state. So no need to go for the next options. So this is the correct answer. So the answer for this question is S1 is equal to 1 half and S2 is equal to 1 half is the correct answer for the singlet and triplet state. Next question is, in energy level diagram for spectroscopic splitting out of the following, which statement is false? The options are: for S, triplet having lower energy than singlet. Option B, for L, higher value of L represents lower energy. For C, for the shell less than half full, higher J means lower energy. Option D, for the shell more than half full, higher J means lower energy. Now we had seen the answer for this question is obviously C option, but why is it C? Let me just show you that. We had seen, in case of an Hund's rule, the value of J means Hund's rule gives you the state with the lowest energy, and it states in its rule that J will be L minus S if shell is less than half full, and J will be L plus S if it is more than half full. Now for if you consider in this option number C, if the shell is less than half full, okay, so it is the first statement I am considering over here. If shell is less than half full, then J is equal to L minus S, which will have the lower energy. Okay, so the option C, which represents for the shell less than half full, higher J represents the lower energy. So the correct answer for this question is the option number C. 13th question is, the gyromagnetic ratio for spin is option A 1, option B 2, option C 3, and option D 4. Now what is this gyromagnetic ratio? We had discussed in our one of the online lecture. You can visit that lecture which discusses the magnetic dipole moment, gyromagnetic ratio and all these terms in detail. So here in this case, if you consider, we know that the electron revolves around the nucleus and it constitutes a current. Based on that one, we have calculated the angular momentum associated with the orbital motion of the electron. That is nothing but the orbital magnetic moment. Now, similar to the orbital magnetic moment, we have calculated the spin magnetic moment associated with that electron, and we got the similar relation like mu L is equal to E upon 2m into L. You got the relation for the spin angular part, that is, or spin magnetic moment, that is minus E upon m into S. If you compare this expression with the standard expression, that is Gs mu b upon h cross, from that one you can see that Gs is equal to 2. Okay, so for the pure spin state, the value of gyromagnetic ratio, which is G, it is nothing but the 2. So here you have to remember that if it is a pure spin state, then the gyromagnetic ratio it will be 2, and if it is the orbital pure orbital case, then the gyromagnetic ratio it will have a value 1. Okay, so for this answer it is a pure spin state it is given, so it is the option number B which is the correct answer. Next question is, In case of LL coupling, if L1 is equal to 1 and L2 is equal to 2, then the total value of uh, capital L R. These are the options which are given over here. Now we know that here L1 is equal to 1 and L2 is equal to 2. Now the total value of capital L, it will be given by L1 minus L2 to L1 plus L2 with integer steps. So here in this case L1 is equal to 1 and L2 is equal to 2. So first of all we'll just take first time difference and the second time its addition. So 1 minus 2 it will be minus 1 and L plus 1 plus 2 it will be 3. So it is if you take its mod it will be 1 2 3. So if you look into the 1 2 3 in the integral steps, then it is the 1 2 and 3. If you look at the option, then it is the option number A which represents the correct answer for this question. Next 15th question is uh, no two electrons in an atom can have same values for all four quantum numbers. This statement is obviously all of us know that it is nothing but it is Pauli's exclusion principle we had seen in our theory lectures. Next question is normal Zeeman effect. The transition occurs between singlet and triplet state, singlet only, singlet or triplet, and triplet only. We know that in case of a normal Zeeman effect, this is the energy splitting of normal Zeeman effect is shown. The transition between any singlet state in an atom with even number of optically active electrons. So if you this is normal Zeeman effect. In case of an anomalous Zeeman effect, you have a transition between the doublet first excited state and doublet ground state in sodium atom. So here you can see uh, in normal Zeeman effect, the transition occurs between the singlet states only. It occurs in the singlet state only. And while in case of a anomalous Zeeman effect, it is a doublet state. So the correct answer for this question for it is the option number B, which is a singlet only state. Next question is for J is equal to 1 and L equal to 1 and S equal to 0, what is Lande's G vector? The options are 1.5, 1, option C 0, option D 2. Actually, if you look at this question, there is no need to solve this question because in this case, spin part it is given to be 0. So obviously the answer it will be 1, which is nothing but the option B, but we'll try to calculate this one. Okay, if you in exam, if you will have some different question, you should be knowing how to calculate this one. So we know that the Lande G factor it is given by G is equal to S into S plus 1 plus J into J plus 1 minus L into L plus 1 divided by 2J 1 plus 1, and this plus 1 will be there. For given state L is equal to 1, J is equal to 1 and S is equal to 0, it is given. If I substitute this value and if I simplify this one, so this term and this term, these three terms will cancel and you'll just get G is equal to 1. So it is a pure orbital state. For pure orbital state in which yes it will be 0, then you will have a G factor equal to Lande G factor G equal to 1, and if you will have a pure spin state, and for that one G will be 2. So you have to remember that in the exam if the question will be in the fashion, if S will be 0 then your G will be 1, and if your L will be 0 then your G will be 2. So here in this case, yes it is equal to 0 it is given, so it is the option number B, it is the correct answer. G is equal to 1 because it is a pure orbital state which is given over here. Next question is the energy of electron belongs to second orbit in hydrogen atom is given by. The options are given over here: 3.4, 6.8, 13.6, 1.7 electron volts. We know that the energy of an hydrogen atom in a with the help of Bohr's model it is given by minus z square m e raised to 4 upon 8 epsilon square n square h square. And this you further simplify, if you substitute this value, we have derived this formula in our theory lectures, which is nothing but the minus 13.6 upon n square electron volt. Now for here in this case it is the second orbit which has been asked. For second orbit means value of n will be 2. If I substitute this value, that will be n square, that will be 2 square. 2 square is nothing but the 4, If I do this division, it will come out to be minus 3.4 electron volt. So if you look at the option, it is the option number A. The energy of an electron belongs to the second orbit. It will be approximately 3.4 electron volt, which is the option A. Next question is maximum number of observed spectral lines for the transition in normal Zeeman pattern for option A 15, option B 35, option C 3, option D 25. Just in our earlier slide we had seen, in case of a normal Zeeman effect, you have a transition between the singlet states, and a single line can be splitted into the three different lines. Okay, so for this question the correct answer is option number 3. While in case of an anomalous Zeeman effect, you will get a more than 3 lines. Okay, that you have to remember. So for normal Zeeman effect, you will have a 3 number of lines. It is option number C. Next question is smallest unit of magnetic moment is Bohr magneton, option C, coulomb, gram and centimeter. We know that the Bohr magneton is the magnitude of the magnetic dipole moment of electron which is orbiting around the nucleus in an atom, and whose formula is nothing but the EH cross upon 2m. So it is the smallest unit of the magnetic moment of an electron which is revolving around the nucleus in an atom. So the correct answer for this question is the option number A. Now next question is the treatment of electron and their orbitals is referred as Hartree level theory, and the Hamiltonian does not consist of more than one electron wave function, option B kinetic energy, option C nuclear electron coulombic attraction energy, option D electron electron coulombic repulsion energy. So obviously in our Hartree level theory lecture we had seen the treatment of electron and their orbital, it consists of more than one electron wave function. So the correct answer for this question is the option number A. Next question is the characteristic X-rays are possible only after option A removal of valence shell electrons, option B removal of core shell electrons, option C removal of loosely bound electron, option D removal of protons. Now we know that in the emission of characteristics X-rays are possible only when you will have a proton which is electron which is removed from the inner shell of the atom, that is we call it as an core electron, and only then you will get a transition over here, or you will get a characteristics X-ray. Means when this inner shell electron it will be removed from the new atom. Okay, the electron from outermost shell it will jump from the outermost level to the innermost level, and during this process the photon it will be emitted. So the answer for this question, it will be nothing but it is the removal of core shell electrons which gives the characteristics X-rays in the spectra. So option B is the correct answer for this question. Next question is according to Moseley's law, option A, the frequency of characteristics X-ray is proportional to the square of the atomic number of an element. Option B, the frequency of characteristic X-ray is inversely proportional to the square of atomic number of an element. Option C, the frequency of characteristics X-ray is proportional to the atomic number of an element. Option D, the frequency of characteristic X-ray is inversely proportional to the atomic number of an element. Now we know that Moseley's law that gives 1 over lambda, that is proportional to the C in bracket Z minus A bracket square. But we know that velocity of a electromagnetic radiation is nothing but the frequency into wavelength. From this one we can write down 1 upon lambda is nothing but the nu divided by C. If I substitute the value in this first equation, then 1 upon lambda, it will be nu by C is equal to Z minus A bracket square. Now from this one we know that C is constant, it means nu is directly proportional to Z minus A square. So if you look at the option, then the frequency of the radiation is approximately directly proportional to the square of the atomic number. So it is the option number A which represents the correct answer for this question. Option A is the Moseley's law, which states that frequency of a characteristic X-ray is proportional to the square of the atomic number of an element. Next question is, X-rays are negatively charged particles, chargeless particles, neutrons. Option C, positively charged particles. Option D, electromagnetic radiation. And all of us know that in our electromagnetic spectrum, we had seen X-rays are nothing but these are the electromagnetic radiations, okay, which are emitted due to the transition between the core and outermost electrons. Okay, so the correct answer for this question is nothing but the X-rays are electromagnetic radiation. So answer for this question is option number D. Now the last question. The Stark effect is related with the splitting of energy levels in presence of option A, electric field, option B, weak magnetic field, option C, strong magnetic field, option D, in absence of electric and magnetic field. Now we have studied in our first module that Stark effect is nothing but it is an electric analog of Zeeman effect. It is electric analog of Zeeman effect. The difference is that in case of an Stark effect you apply an electric field, whereas in case of an Zeeman effect you apply a magnetic field. So if from that point of view if you look at this option, so the Stark effect is nothing but it is an electric analog. So Stark effect is related to the splitting of energy levels in presence of an electric field. So the correct answer for this question is the option number A. That's it for the today's session. I hope you people have understand the lecture multiple choice questions which we have discussed in our today's session. I request all you people for the upcoming video lectures on the module number 2, 3 and 4. Please subscribe our channel Basics of Physics by Professor Ravikiran Late, and please hit like button and also hit the bell icon button for the future notifications. That's it for the today's session. We'll stop here for today's lecture. Thank you.